section 5.3, day 1, and we're still talking about area. We will be this whole unit, and today we're specifically talking about the definite integral. And so sometimes these two terms mean the same thing, and sometimes they don't. So we're going to kind of look at that today. Our essential question then is, how is the definite integral expression written? So we talked a little bit about that in section 5.1. We're going to come back to that. And what strategies can be used to evaluate the definite integral? So we're looking at strategies here. So finding definite integrals on your calculator. The nice thing is your graphing calculator can do this for you. So we have something that's called the Math 9 key. So it's right next to your Math 8 key that we use when we were differentiating. And that's the definite integral function. So it's able to then, you're able to put in this information and get the answer for the actual area underneath the function, between the function and the x-axis. And so this function x squared, which we work with a lot, if we integrate it from 0 to 5, we get this sliver of a shape here that has a curved surface. And that region between the function and the x-axis is 41 2/3. So this is how we do this. I have two different displays here. One is a display that you find on most newer calculators, and one display that you find on older calculators. So the newer calculators, the newer 84s, have what we call math type. And so math type allows you to put things in that look a lot like how we would write them in calculus. So if we want to integrate from 0 to 5x squared, we do Math 9, and this comes up and there's boxes. And in these boxes we'd put a 0 and a 5 and our function, and then our dummy variable dx, or just x. And you hit enter and you get 41 2/3. So we have to recognize this as a repeating decimal as 2/3. If you have an older calculator, so these are the older 84s or 83s, it's still Math 9, but you don't get this nice display. You get something called, you get syntax, and this is kind of computer talk, and so you get this syntax that says fn int. And fn int means just basically function integration. And then we have a bracket here, and we put the same information up here as we do here. Here's the function that was found here. Okay. Here's the dummy variable that was found here. That's what that represents. Here's the lower bound. That's there. And here's the upper bound. That's there. And then when you type in enter, you'll get the same answer. So that represents then that 41.667, or 41 2/3, represents the value of the area of this region. And again, I want to stress, it's the region between the function and the horizontal axis. And since this region is above in the first quadrant, we're going to get a positive answer. So with this information, we're going to look at some properties that will help us evaluate definite integrals, knowing this number and then not having to use a calculator after we know this number. So for instance, here are 5 properties that are really common. One, we're going to look at them one at a time, and we're going to put examples down here. So let's look, let's start with the fact that we know that this entire region is 41 2/3. So we've already calculated that. Now let's talk about doing some of these things. So for instance, question 1, or not question 1, property 1 says reverse your limits. So notice what property 1 says here. The order of integration, lower bound B, upper bound A. Now what happens in this display is I swapped them. Now I have A and B. When I swap them, that's like sweeping from the right to the left on the graph. And so that's sweeping through the region backwards, and so we're going to put a minus sign in front of that. So for instance, if we know this is 41 2/3, if we go sweep from 5 to 0, we sweep backwards, that's going to be negative 41 2/3. So sweeping forwards and sweeping backwards have two different values. This has to be different than this because it's not the same. So it's a negative value. It's represented by sweeping backwards. Let's take a look at property 2. Property 2 is no accumulation. So notice property 2 says I start at A and end at A. That would be like starting at 3 and ending at 3 right here. So that's represented just by this single line on the graph, which means that I have not accumulated any region whatsoever, so I can't have any area. Property 3 says let's multiply the function by a constant. So instead of x squared, I would have like 3x squared. Well, I should be able to take the constant right out of here and then work with the original integration. So for instance, I decided to have a constant that's a fraction, a half x squared. So think about a half x squared. If this is x squared, then a half x squared is just my y values are all cut in half. So now I'm talking about this region here with underneath the blue line, between the blue line and the horizontal axis. Okay? And so that region then, if I integrate from a half x squared from 0 to 5, so I'm going to integrate across the same region, that's the same as saying half of the integration that we did before. And so it's literally half this area. So that region is half of 41 2/3, which is 20 5/6. So that's property 3. Let's talk about property 4. Property 4 is sum and difference. So property 4 is saying if I've got two things added together, I can give them each their own integral sign. So for instance, let's say I had x squared plus 4. So if this is x squared, then x squared plus 4, and I'm going to go from 0 to 5 again. X squared plus 4 is shifting that up 4 units. Let's do that again. Okay, if this is x squared here, the red region, then x squared plus 4 is just shifting that whole thing up 4. Well, what did that do to my shape? That created a region down here underneath the red region. And that region is represented by a function 4. So that means I can split these up into my original integration from 0 to 5 plus integrating 4 from 0 to 5. And we've done this before. That's this region, which is a rectangle. And the area of this region is 4 times 5. So it's going to be my original area plus 20. And so if I add those together, I get 61 2/3. So that's property 4, sum and a difference. We're going to use this property a lot. And then property 5 is the additivity property. In other words, a sum and a difference is a vertical shift. The additivity is a horizontal split. So in other words, I can take my original function from 0 to 3. I don't know that answer. But if I add to it my function from 3 to 5, I have now accumulated across the entire original region. I know that that sum is 41 2/3. So if I did each one of these on my calculator, I would get 9 for this, and I would get 32 2/3 for this, and that, sure enough, that equals 41 2/3. So this is kind of like the pieces add up to the whole. Okay, the green piece and the blue piece add up to the whole value. So those 5 properties we'll use a lot through the course of Unit 5 and beyond. So let's use some of those properties to find these values, to solve these problems. We have these 3 values. If we don't know what these functions are, f of x and h of x, we don't know what they are, we don't really care. All we know is that we are accumulating the region below f of x, between f of x and the axis, the x-axis, from -1 to 1. And when we accumulate that region, we find it's equal to 5. And then if we go from 1 to 4 under this, between the same function and the axis, we get this region of -2. And then if we have a different function that also goes from -1 to 1, so the same bounds as this, and underneath that function is 7. So let's try some of these properties here. Here, question A is saying, let's take f of x, and let's go from 4 to 1 instead of 1 to 4. Well, we know that the property then, it's a property 1. We know that that is just the opposite value of what we see here. So that means I can use property 1 to put a minus sign here and switch my bounds to make it look like this. And so I'm going to take the opposite of this answer, which is 2. Question B says I want to accumulate f of x from -1 to 4. Well, I've got from -1 to 1 and 1 to 4. So I can use my property 5 to add those together. And so it's going to be from -1 to 1 and 1 to 4, and that's going to be 5 plus a -2, which is going to be 3. So there's 2 examples of properties. Part C, now I'm starting to get a little fancy here. I want twice f of x and 3 times h of x. Okay, so that's that multiple rule. And I'm going from -1 to 1. F of x, we have that, and h of x, we have that. So this is kind of a combo here. It's a property 3 and then a property 4. So I'm going to split this up, give each its own integral. So here's for function x from -1 to 1. And then I took the 2 out front. That's my property. That's another one of my properties, my multiple property. And I'm going to do the same thing for function h. Take the 3 out front, give it its own integration. And now notice this notation and this notation are represented up here. So this is 5, so I have 2 times 5. And this is 7, so I've got 3 plus 7, or 3 times 7. I've got to add those together. So I have 10 and 21, that's 31. D, I'm going from 0 to 1 of f of x. So I don't have information from 0 to 1. So I can't do anything with that. I can't assume it's exactly half. I don't know how it's distributed, so there's not enough information. I need more information here in order to determine this answer. So we can't answer that one at this time. So we don't have a property for that. However, example E does the same thing with H. H goes from -1 to 1 typically, but I'm going from 0 to 1. I'm just looking at the right-hand side of H. And we have some additional information here. H is an even function. That means H has symmetry, left to right symmetry. In other words, it's symmetrical about the y-axis. That's it. Like an even function would be x squared, if you can picture that. Right? X squared is symmetrical about the y-axis. We can cut it in half right down the axis. And since we have this additional information, then we know that the left-hand side and the right-hand side, as long as it's symmetrical about the y-axis, symmetrical about 0, the left-hand side and the right-hand side are the same. So we know that this is then a property 4. We can split this, and we know it's half from -1 to 1. So it's going to be half of 7, which is 3.5. So there are some examples there. Oh, I have an example F. Whoops. So let's go from -1 to 4. And let's add f of x to h of x. So I'm going to, it's a property 4 and 5, it's a combo again. And I could split those from -1 to 4 of f of x. We can do that. We did that before, that's a 3. But then I have from -1 to 4 of h of x, and I don't have that information. I only have up to +1. So from 1 to 4, I'm missing that piece of information, so I cannot determine an answer for f either. So at this point, you should be able to do section 5.3 day 1 homework. It's going to be a lot of calculating the values of the definite integrals on your calculator using your Math 9 key, and it's also going to be using those properties, just like we got done with those examples, where you have values and you have to apply the properties to find the answers.